Welcome back to System Software. So today we're going to go over using the command line and navigating the file system, modifying the file system. Last time we went over the file system itself, the theory behind it, and today we're actually going to use this knowledge in order to orient ourselves, navigate the file system, and modify it. Before I do that, let me go over the homework from last time. So last time the homework was to take a list of paths and reconstruct the file tree from this list of paths. And remember that there were two kinds of paths, two kinds of ways to specify paths on the file system: absolute and relative. Absolute paths are paths that start with a /, that is, they start with the root directory. Relative paths, in order to know where on the file tree this file is referring to, we need to know the working directory. And every process has a working directory as managed by the operating system kernel. And when we're in the shell, as we'll see today, the shell will maintain the working directory, and you'll be able to refer to files using a relative path from that working directory. Okay, so let me go through each of these paths and construct the full file tree from it. So let's take the first one. Our working directory is home, but this is an absolute path. So the working directory isn't taken into account for this path because we already have an absolute path. We already know exactly where on the file tree this file lives. So starting from the root, every file system has a root folder denoted by /, and this absolute path starts from root and then brings us to the home file. As we'll see, this home file is a directory. And similarly, for the next line, /dev, this is also an absolute path. So even though we're in the root as a working directory, that's not taken into account when trying to determine where on the file tree /dev is. /dev is also an absolute path. It starts with a /, and therefore dev is underneath the root directory. For boot, the same applies. No matter what the working directory is, because we have an absolute path, we know that boot is a child of root. So this working directory could be anything. If we have an absolute path, this working directory, we don't need to take it into account in order to determine what directory the absolute path is referring to, or what file it's referring to. Okay, now we get to relative paths. So here the working directory does matter. Here we're in the working directory of root, so I'll use this orange dot to denote the current working directory. So if our current working directory is also root, then relative paths are effectively like absolute paths. One way to think of it is that we append prepend the working directory to the path, so we get / and then whatever the relative path is, user. And so this user file is also a child of root. And again, at this point, I don't know whether it's a folder or not, but we know that it's a file. Okay, so now we have a different relative path here. This path, the working directory here, is home. So I'll show that by moving this dot to denote the working directory to the home directory. So if my relative path is just Paul, then it's relative to the current working directory. We can think of this as concatenating /home with the slash or with the Paul folder or file. So this Paul file is a child of home. Here's where we get to see the use of ... folders. Now my working directory here is dev, so let me move the working directory dot to be dev. And so remember that each folder, or each folder in the Unix world has two special folders, a dot folder, which refers to itself, and a ... folder. The ... folder is a hard link to the containing folder's parent, the containing directory's parent. So dev's ... directory is a hard link to its parent. Okay, so we're in the dev working directory. Let's follow this relative directories sequence of paths to figure out where this path is referring. Okay, so we start in the working directory /dev. Then we follow the ... directory. The ... directory is a hard link to the root. The next element of this path is /home, so that brings us to the home directory, the child of root. The next component of this path is Paul, so that brings us to the Paul directory. So this doesn't tell us there's any new files. This is actually the same file as the previous entry, where we had home as the working directory, /home as the working directory, and Paul as the relative path. This line here, where we've got dev /dev as the working directory, and ... /home /Paul, these are actually referring to the same file, because we've used ... to move to the root directory and then referred to /home /Paul. So there's one more component to this path here, /src. So this /src is a child of /home /Paul. So to go over this one more time, when we're in dev, we follow ... to go to our root. From root, the next component is home. The next component after home is Paul, and then source. Okay, let me do the next entry. So here the working directory is /user, and the relative path is bin. So bin, again, taking /user and concatenating it with bin, we get /user/bin. Our working directory is user, and so the relative path refers to a file that's immediately a child of user. Let's go to our next working directory. Our next working directory is /home /Paul. So here's our working directory. And here, our relative path is ./bin. So remember that each folder has a dot folder and a / folder. The dot folder refers to the directory itself, and ... refers to the parent. So in this case, dot just refers to Paul itself, and then following the / the child is bin. So in this case, if our working directory is /home /Paul, a relative path of ./bin and just bin, those would refer to the same file. Why are these two bins different? These two bins are different because they have different working directories. So this bin is the child of ./ because that's the work, or /user because that's the working directory we're in. And this ./bin is a child of /home/Paul, because the working directories are different. Okay, and so to finish this up, keeping the work directory /home/Paul, where does this home file live? Well, it's not this one, because our working directory is /home/Paul, so our working directory is not this, or our directory is not this home. Our working directory is /home/Paul, so the home here is actually a child of Paul. Okay, so let's take this last, more complicated one, referring to another Paul file. So let's see whether or not it's the same as this Paul. Our working directory is also something a little more complicated. It's /dev /home/Paul, and then /home, this other home directory. So our working directory is this home directory. So if we have Paul relative to this home directory, we have a different file or directory here. Okay, so that's the solution to the last homework. Okay, so let's do the presentation from today. Navigating the file system from the command line. So take a look at the syllabus for guides on using SSH on your particular operating system. And so I'll assume you're able to log in to use this. Let me know if you have any issues, ask on ed discussions or come to office hours. But I'll assume that you're able to get into use this. And so you can get into use this like this, SSH your NID at eustace.eecs.ucf.edu. Okay, so you should see something like this when you log in. You'll see a welcome message and a prompt that has your NID at some host name. So one common shortcut that I use frequently is Control-L. Control-L clears your screen. So if I've typed a lot of stuff, I can use Control-L. You don't have to type out. You can also type out the clear command, but Control-L will also do that for you. Okay, so in order to run commands, we put a name like pwd and just hit enter, hit the enter key. So there's two things that I always do when I'm in file tree, just to orient myself. I use the pwd command, print working directory, and ls for list. So these two commands will help you orient yourself in the file tree, because pwd will give you an absolute path to your current working directory, so that any relative paths you use will be you'll know what it's relative to. You'll know that it's relative to the to this current working directory. And ls just lists all of the files that are in your current folder, all the children of the current working directory. Now, commands also take arguments. I could, and these arguments are command specific, so ls will take a path to another directory that you'd like to list. So I could, for instance, use an absolute path to the user include directory, which includes C header files, system-wide C header files. And I just type ls space and then the name of a path. And that will pass an argument to ls to change its behavior. So typing that, you'll see I'll get this long list of .header files. If I made a mistake in typing the path, it will give me an error telling me that there's no file at that path. Okay, so we've seen where am I with pwd, what's here with ls, and let's look at how we can change the working directory. So let's change our working directory to this user include folder. Notice that on this shell configuration, the prompt will actually include the name of the path that of our working directory here for us, which kind of helps orient ourselves. You can also see that with pwd. The tilde path is just a shortcut for your home folder. So if I change directory to tilde, that will put me in the administrator-defined home folder for you. Each user will have its own home folder, their own home folder. Okay, so let's use cd to go to the include directory. I'll clear the screen, see where I am, list what files are here. So this is an absolute path. This path I went to is an absolute path. I can also use relative paths. So for instance, the .. folder is the parent folder. So what folder, what directory will I be in when I change the working directory to the parent of the current folder? Well, I'll be in /user. So we can confirm that with print working directory. Now I'm in the user directory. I can also use other types of relative paths like to enter this subdirectory. So to go back into this include directory, I can just cd include without typing out the whole absolute path, because the path that we're going to change directory to is the working directory here, concatenated with whatever relative path I pass on the command line here. So one kind of quick question is, what if I had changed directory to, so here I'm in /user/include. What if I change directory to /include? What directory will I be in? Well, I'll be in the same directory, because .. will take me to the parent, which is /user, and include will take me to the include path, which is the same path that I'm currently in. Okay, so let's see some useful tricks for navigating the file system much faster than typing out everything. The first and probably most important and useful trick is tab completion. This is a feature of Bash and other shells that will automatically type for you, like autocomplete. It is autocomplete, actually. I think it predates autocomplete on phones. It will automatically fill out paths for you. And this satisfies a couple of the programmer virtues that we talked about in the first class, one being impatience. So don't spend time having to type out each path when you can just use tab completion or autocompletion to fill out paths for you. And also laziness, because instead of having to try to remember the whole file tree, instead of having to type ls all the time, tab completion will actually also list out what files are there available for you on the command line. All right, so let's take a look at a couple of examples. So here we're in /user/include. If I type lsgnum and I don't touch anything else, I don't hit enter. If I hit tab, the tab completion system is going to write the rest of the file name for me. So I can appear to type really fast with tab completion, but really I'm just hitting a single key, tab, in order to fill out the whole name of the header file, gnumake.h. Now that works great if there's only one file that starts with gnum, but what if there are multiple files? When I hit tab, no completion happens. Hitting tab a second time will list out all of the files that have the GNU prefix for me. So I can just keep hitting tab whenever I'm trying to navigate or look at files in my file system. And the tab completion system will explore for me, help me interactively explore what files are available to me. And then once I continue typing, so here I put the hyphen in, and once we have an unambiguous prefix, a prefix that can only go to one file, hitting tab again will give us the unique file path. So to make things fast for you, make it a habit to hit tab, because not only will it help type for you, it'll help you confirm the existence of a file. It'll make sure if you, say, have a typo, hitting tab and getting nothing will give you a signal that that file doesn't exist. More importantly, instead of typing out paths yourself, use tab completion to not only type for you, but also confirm that that path is there, that that element of the path is there. And by hitting tab multiple times, it will list out for you all the possibilities, so you can interactively explore this file tree. Okay, there are also some, to make things fast, you can also edit the commands more quickly. And here's just a little cheat sheet for editing commands. Control A and Control E will go to the beginning and end of a line. You can also use home and end on your keyboard, most likely in your terminal. Backspace deletes characters. Alt backspace will delete entire words for you. So you don't necessarily have to remember all these right now, but you can kind of learn these as you go along. Similarly, for deleting characters and moving around between characters, you can use Control D to delete a character in front of you. You can use Control B for back, Control F for forward, and you can use, just like you can use Alt Delete to delete a whole word behind you, you can use Alt D to delete a word in front of you. There are also shortcuts for cutting and pasting, and I'll just let you explore these on your own time. Okay, so another really important tip for the command line is being able to rerun commands you've written already. So if you spend a lot of time, say, typing out a GCC command, some long GCC command, instead of having to rewrite that or remember what the entire command was, impatience and laziness, you can use the history in order to repeat prior commands that you've used before. So here you can use Control P or the up arrow to immediately type out the previous command that you've written. And you can cycle through all the previous commands you've had by hitting the up arrow or Control P for previous. If you want to go back down to later commands, hit the down arrow or Control N for the next command. And in fact, the history command will print out the entire known history of commands that you've written in the past, up to some threshold limit. So this is really useful for not having to type out some complicated command that you've already figured out, or also going back and inspecting what you did on the command line. So with tab completion, the command history will help make running and rerunning and, say, recompiling and testing code much faster on the command line. Another little trick that I'll let you explore on your own, you don't necessarily have to remember this, is you can search for previous commands with Control R. So you type R and start typing text, and it'll search your prior command history for prior commands that you've written. One little trick that works along with command histories is you can kind of sort of save a command by commenting it out. The hash symbol is the comment in bash, and so if I find some previous command, I can use home or A to go to the beginning of the line, Control A, insert a hash, and when I hit enter, this command won't be run. but it will become the most recent command. So if I go back and delete that hash symbol, I can run GCC. So here I made an error. I can go back, fix the command, and rerun this modified version of a previous command. Okay, so those two tricks, there's several tricks here, but the two main tricks to remember here are tab completion to make typing paths really fast, and the history to make repeating previous commands really fast. So I should also note that tab completion is not just for files, it's also for commands and arguments to commands. So for instance, for the ls command here, if I type // which is the convention for arguments, and hit tab, it will tell me all the other options that are available for the ls command. If I say type C here and use tab completion, it will tell me all of the programs that are available or commands that are available to run that start with C. Okay, let's look at a few more commands here. So cat, also short for concatenate, will write files to the terminal for us, or write files to output for us. That's the cat command. More is like cat, but if I have a particularly long file, like let's say I want to print out standard.io.h, it will only show one page full of text at a time. So I can hit space to go down an entire page, so you can see it maintains a percentage of the file that I've seen so far, or enter to go one line at a time. If I want to stop early, I can use Q. One problem with more is that it only goes in one direction. Once you've seen the top of the file, you can't go back and revisit the file. Oh, actually, and this command has been updated. So historically, you actually can use page up to view prior commands. I think before more was modified, there was a new version of more called less. The joke is less is more. And with less, you can do more than just navigate the file, navigate up and down. You can search for files. I think you can write stuff out. So anyway, I use less more often. It's has a little more complicated interface than more. But if you find yourself stuck in the less program, use Q or escape Q to get out of the less command. Okay, so those are examples of the commands, some keyboard shortcuts for navigating the less command. So let's look at something that we're going to use for homework. So for homework, I've given you a file tree here in this tar file. A tar file is just like a zip file. It's a package. And you can download it from the command line with the wget command. Wget, you give it a URL, and it'll download the file at that command. You can do other things like scrape websites as well, download multiple, follow links. But here we're just going to use it to download a single file, this hw3.tar file. So let's run this command here, and you'll see that it'll save the hw3.tar file for us. We can use ls to confirm that it's here. Even better, we can use ls and then tab completion to help us put the name of the file. To unpack this file, you can use the tar command. So I've explained what these arguments are, but for our purposes, you can just remember or copy this tar command here. And tar has unpacked all of the directories and folders, and directories and files that were packaged in this hw3.tar file. Okay, so this is what you'll start with in order to modify the file system for homework 3. So for homework 3, your task will be to take the existing tree here So if we look at the, oops, I missed the command here. We're supposed to download the file, untar it, and then change directory into homework 3. So here we are in homework 3. If you type tree and the current directory, you should see this file tree. Note that the order of the files are not maintained in a directory. They're going to be whatever order they happen to be entered in. So the order of just like a tree structure, the children are unordered in a typical tree. The order of these files doesn't matter, but the tree structure is what should be the same. So you should see that fs has ext2 as a child and ext2 has acl.c as a child. So you should see something similar modulo the order of children in a directory tree. And the homework is to write a sequence of commands, bash commands, that will turn the given tree into the new tree written here. Okay, so let's first go over the commands that we can use to modify a file tree. So let's make an example folder here. Okay, so touch will create a regular file. So I'm going to touch reg file, and now when I type ls, I have this new file, reg file here. rm for remove will remove a regular file. So you can see our file is gone. Okay, so let's make a new file here, reg file 2. Move, when moved within the same directory, is effectively rename. So I'm gonna, the move command takes 2 arguments. First is a file or path to a file that you want to move from, and the second is the new path or new file name of the file. So when I type move reg file 2 to reg file new name, I should see, when I type ls, I should see reg file new name in this directory. Copy has a similar interface. So if I want to, but instead of moving it, it'll make a new file that has the same contents as the old file. So here now I have 2 files. mkdir or make directory will make a directory for us. So let's make a directory called subdir. My terminal will use, it's because I have color coding, it will actually color code the types of files to help identify what they are. And we can move not only to change file names, here's reg file copied, we can also move to new paths. So if the second argument is a directory, instead of renaming the file, it will move that entry from whatever directory we're currently in to the given directory's entries. So here we can see that reg file copied is no longer in this directory, but if we use tree or ls the subdirectory, we can see that reg file copied is now in the subdirectory. You can also use, if you put not just a directory, but you put a file name, then it will not only move reg file new name to subdir, but it'll also give it a new name in subdir's directory entries. So you can see that now reg file new name has become new file name under subdir, and it indeed is under subdir's directory entries. We can remove an empty directory with rmdir. So let's try to remove subdir. But because the directory is not empty, the subdir command or the remove dir command is not gonna remove it. So how can we actually remove the contents of a non-empty directory? Well, one thing we can do is we can use the rm command to remove whatever files are in here first. And now that we've got an empty directory, we can use our emptier. So how could you write an algorithm to do this? Little something to think about. There are additional options or commands to the RM to remove non-empty directories. I'll let you take a look at these themselves because they can easily be used to blow away your whole file system. Okay, so just to let me go over what the homework is first. So, and an example of the homework. So, starting from your home directory, so you can type cd tilde. Shortcut is to just type cd, which will take you to your home directory. You'll download. So, let me show downloading, untarring this again. I've already downloaded it, so the wget command will not overwrite what you've downloaded. It'll just make a new file. Download it, tar it, untar it, and then enter the file tree. So to go back to home, use cd. If you find that you've made a mistake in your homework 3 folder and you'd like to try again, you can move the folder out of the way into some new folder. You can also move folders. And so now I don't have a homework 3 directory anymore. So if I go and untar this file that I've already downloaded, I'll get a new homework 3 directory. So do that if just move the old version out of the way if you find that you've made a mistake. So now go into the homework 3 directory. Here's what the original tree looks like. And now our goal is to turn the original tree into this tree using really only the commands that you only need the commands that you see here. You should only need these commands to turn this directory tree, the previous directory tree, into the new one. So this is a little bit of a puzzle solving exercise because you've got to compare these two trees and see what's different. Now notice here that FS is in a different place. The order of directories the order of children in a directory are irrelevant. The operating system doesn't enforce any particular ordering, doesn't remember any particular ordering. So this is just like a general tree that you might have learned in CS1 or CS2. They're order insensitive. What the file system does maintain is the structure, the parent-child relationships between the files in the tree. And so that you just want to make sure that even if you're in a different order here, that your file tree structure is the same as this one. Okay, so let's take one example here. Let's take fs ext2 acl.c, this set of files here. So in the new tree, the structure is similar, where it's fs and then a child that has acl.c. But the name of this child is different. The name is ext4 instead of ext2. So there's several ways you could solve this. So one way is to rename or move ext4. So you could enter the fs directory and rename it here. But you don't actually have to do that because these commands for file operations will take paths instead of just a single file name. So we could write the path to ext2 using tab completion to help us. And we could give this directory, ext2, a new name with the second argument and give it the name ext4. So now when I look at my tree, the fs directory now contains a file called ext4 instead of ext2. So take your time doing this. Look what's different between the trees. Then look at the commands that are available to rename or move, copy, delete, make new regular files, or make new directories, or remove directories. And yeah, use the tree command to confirm whether your new tree matches the one given in the homework. And remember again that the order of entries for a particular subdirectory doesn't matter for the file system. So if you see fs before HID here, for instance, then it's still the same tree. Just make sure that the tree structure, that is the parent-child relationships, are the same as what's given in homework here. Okay, so that concludes the lecture for, or actually, let me review. I added a review section here for the for what we learned today, what to kind of take away going forward in this class. I showed a lot of material, but there's a small number of things that you should absolutely remember, and look at this review section to remember those. So the first is orienting yourself. So use PWD and LS to figure out where you are and what's here. Use change directory to move around the file system. So to change your working directory. So here's examples of going to a directory, going to a parent. You can go to the home folder with change directory tilde. You can use CD hyphen. So this is a hyphen. This is a tilde. This will take you back to whatever directory you were in previously, and you can use the bash history to go to the previous command and quickly swap between two directories. CD without anything will also take you home. Tab completion is one of the most useful things to make typing fast, so I can very quickly type out the path to user include very, very quickly by hitting tab before I complete typing one element of the path. So I can very quickly, just with 1, 2, 3, 4, 5, 6, 7, 8 presses on the keyboard, I can change directory to this path. The history, so being able to hit the up arrow or control P to navigate to, or to inspect prior commands that you've run. And here's just a list of modifying the file tree. All right, so that's all. Should be all you need for completing the homework, and I will see you next time.